Hi, this is Vasavi from At Home Tuition. Today we are going to learn one important theorem in the chapter triangle. It is Thales theorem. You can also call it basic proportionality theorem or BPT theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, then the other two sides are divided in the same ratio. To prove any theorem, we need to know two aspects. You should know what must be proved. And secondly, you should know what informations are given, right, to prove the theorem. So in this theorem too, let us gather these two details, okay? So I take this part of the theorem. So this is what is the information given, okay? Let us picturize it. What is given, I have put it in a picture. So we have a triangle ABC. So we need a triangle ABC and a line drawn parallel to one side of this triangle, okay? So the side I have taken is BC and I have drawn a line parallel to BC and the line is DE, where the D cuts the side AB and E cuts the side AC, okay? So the information given I have plotted here. Given triangle ABC with DE, the line DE parallel to the side BC, right? Okay, this is what is given. Let us check on the statement of the theorem again. The next part of the theorem says the other two sides are divided in the same ratio. So that is what you need to prove, right? So to prove, simple, the other two sides are in the same ratio. That is AD over DB is equal to this side, it is AE over EC. So this is what we need to prove, right? Okay. Now for this proof, let us use the area of a triangle formula. So what is the area of a triangle? Half base times height, right? Half base times height. We use this to compare the ratio of the lengths needed in this proof, okay? These lengths. So we are going to use the area of a triangle to compare the lengths of the sides. We'll go to the next picture here. I have just made this into three different pictures so that you can get the idea clearly. So the same triangle is here, and what I have done is I have made two triangles. One triangle with this green color and the other triangle, that is, I take that green color triangle ADE, and I take the base as AD. Okay, take this the side AD as its base, and I have also drawn an altitude from the opposite vertex straight to your base, so that will be your height. I take this height as H1. So now the area of triangle ADE, okay, the green triangle ADE is equal to half times the base. Base is AD here, right? I have taken the base as AD, and so my height is H1. Now, what is the area of triangle, the violet triangle there? I have taken another triangle BDE because I need BD also, right, as base. So I am going to take this half. First I took this as my base. Okay, now I am going to take this part as my base. So that triangle is triangle BDE. Okay, BDE. Here again the formula is half. Here the base is BD, right? And the height of this triangle is also H1, because I tell you, if this is the base, BD is the base, your height should come from the opposite vertex, right? So from here the straight line would be the altitude of this triangle. So that is H1 here, okay? A 90-degree perpendicular line from the opposite vertex is H1. So that is H1 here. Now I put this in the ratio, okay? So I make, let me make that in the ratio. So area of triangle ADE over area of triangle BDE will be equal to, area of triangle ADE is half AD times H1, right? Divided, the whole thing divided by half area of triangle BDE, okay? So that is BD times H1, right? Now your half and half will get cancelled. H1 and H1 get cancelled and you're left with AD over BD or DB, whatever, okay? So we got this part of the left hand side we have got. Okay, I take it as equation 1, okay, for time being. Now instead of drawing in the same triangle, I have just drawn it as another triangle here so that we are not confused. This time I am going to deal with this side, okay, the side AE and EC. So for here again I take the triangle, area of triangle, the green one is ADE again, ADE, but this time the base is AE, okay. So here it is half, the base is AE here, and the height, I have to get the altitude on that base, right? So from the vertex opposite I have just drawn a straight line, perpendicular line, and I take it as H2 for time being. So here I write H2, okay. Now then you have area of this part EC, right? Is the triangle with base EC. So triangle EDC, let us take it as EDC. This is again half and the base is EC this time, okay, times H2, okay. Now let us put these two in the ratio now. So that is area of triangle ADE divided by area of triangle EDC. So that would be half times AE times H2, right? The whole divided by half times EC, the base is EC, times H2 again, okay? The height again from D, when you draw a straight line, it is H2, right? So for the triangle EDC also the height is H2. Now again your half and half gets cancelled, H2 and H2. The heights get cancelled as they are all same. So you have AE over EC. Got it? Okay, this is equation 2. Now look at the third picture here. Here I have just drawn two triangles. One is, I can say, triangle BDE. Area of triangle BDE is equal to area of triangle EDC. Okay? So there's nothing to confuse. You would have learned in earlier classes that the triangles on the same base and within the parallel sides, two parallel sides have the same area, right? So here the base is DE. This base is the same for both the triangles, that is BDE, the base is DE, and EDC also, the base is ED, and the height between the height of both the triangles, say for instance if I draw the height here, and here both is going to be the same, right? So the height is the same. So when the base and heights are same, then the area of the triangle is equal, right? So I write the reason also here, because they have same base and height. Same base, I call it DE, okay? And are within, I can also say that, are within two parallel lines, okay? So this is the reason why we say that these two areas are same. Now since these two are same, I can put that from 1 and 2. Area of triangle ADE divided by area of triangle EDC is equal to area of triangle ADE divided by area of triangle BDE. Since these two are same, this is equal to this, right? And the numerator is already the same. So this implies AE over EC is equal to AD over BD. So this is proved. I have proved the BPT theorem. Basic proportionality theorem proved. Hope you understood this. It's one of the important theorem. Basic proportionality theorem is very important from examination point of view. So learn it well. Thank you. Bye.